When we complete the square of a quadratic, it means we will be putting it in the form of x plus a new value p plus q. So here are the stages. Firstly, we write out the bracket x plus b divided by 2, and b is our coefficient of the letter term, which we divide by 2. We then square that whole bracket. Once we've done that, we'll look at that, and then we will figure out what we need to add or subtract to get the original expression. And you see here I'm working with quadratic expressions rather than quadratic equations. When we're completing the square, there are quite a few videos on YouTube that will show you how to use completing the square to solve a quadratic equation. And whilst we will move on to that, right now we're going to work on how we put a quadratic expression in completed square form. And that's quite important, particularly if you want to see the turning point or to be able to move the actual graph, to transform the graph. So let's work through a few example questions, and it'll become easier as we work through each one. We need to write x squared plus 6x minus 5 in completed square form. And if we remember, the general form was x squared plus bx plus c. So b equals 6, and that means b divided by 2 equals 3. And so our bracket will be x plus 3 squared. And then if we were to expand this bracket, that would give us x squared plus 6x plus 9. And if you look at our original expression, we wanted -5 and we have +9. So what do we have to do to make +9 into -5? We have to subtract 14. So that expression there is now written in completed square form. We go on and try a few more. We have x squared plus 2x plus 6. I've written the form there again. B equals 2. So b divided by 2 equals 1. Open up the bracket. X plus 1 squared will give us x squared plus the 2x that we want, but 1 times 1 is 1. So at the moment we've got +1, but we want a +6. So what do we need to add on to this to make it +6? And that is 5. Let's do another. X squared plus 8x plus 81. B equals 8. So b divided by 2 equals 8 divided by 2, which equals 4. And that means x plus 4 squared, and that will give us x squared plus 8x plus 16. We wanted +81. We have +16, so we need to add on 65. Here we've got a negative value, so we've got an x squared minus 12x plus 100. And our general form was x squared plus bx plus c. So b equals -12. That means b divided by 2 equals -6. So our bracket will be x minus 6 squared, and those brackets expanded will give us x squared minus the 12x that we want, and a -6 multiplied by a -6 is +36. So to make the +100, we need to add 64. Now they all look relatively simple so far, but as with most maths, they do get a little trickier, especially when we deal with an odd coefficient of x. So when we deal with an odd b value, I'll give you an example. If we have x squared minus 5x plus 20, you can probably see that when we divide -5 by 2, we're going to get a fraction, which can be a bit of a pain, but as long as your fraction skills are good. If you are slightly wobbly on your fraction skills, I have got another video on fractions and I will link it at the end. It covers everything to do with fractions in 5 minutes, so that you might find that really helpful, particularly for completing the square. So here we have b equals -5, and so b divided by 2 equals -5 over 2, and leave it as a fraction. That's the one thing with completing the square. You can end up coming across quite a lot of fractions, and it's best just to leave everything in fraction form. This gives us x minus 5 over 2 squared, and if we expand those brackets, we have x squared minus 5x and then positive, because a negative multiplied with negative is a positive, and 5 times 5 numerators is 25, 2 times 2 for the denominators is 4. Now the way I do this is if I take a look at what I originally wanted, a positive 20. We need to figure out what we need to add to 25 over 4 to get 20. And the best way to do that is to change 20 into fractional form by putting it over 1, and then we're going to make the denominator 4. So to make the denominator 4, multiply the bottom by 4 and the top by 4. So that means 20 over 1 becomes 80 over 4. And then we need to subtract the 25 over 4, and that gives us 55 over 4. And that's what we need to add to complete the square. Now we're going to go on to actually use completing the square to solve quadratic equations. We have the quadratic equation here, x squared minus 4x plus 1 equals 0. First step, we put it in completed square form. And so we have b equals negative 4. b divided by 2 gives us negative 2. So the bracket is x minus 2 squared. That would be x squared minus 4x plus 4. We wanted plus 1, so we have to subtract 3. So we subtract 3, and that equals 0. And now we just go ahead and solve like a normal equation where we want x on one side and numbers on the other. The first thing we're going to do is we're going to move this negative 3 over to this side, and being a negative, we need to turn it into a positive. So we're going to add 3 to both sides. That gives us x minus 2 squared equals 3. Next thing, we want to remove the squared term, so we're going to take the square root of both sides. Now I always write my operations down the side here. Couple of reasons. I like to be able to look over and see what I've done, but more importantly, if we're doing this in an exam, it's good for the examiner to see the stages that we've used, because there could always be a mark, a credit for that. I find it's always worth showing each stage of your working out. Good habit to preserve. So when we take the square root of this, that loses the squared term and we're just left with x minus 2. And on this side, the square root of 3, that will give us a positive or a negative root 3. And this part is really important, because if we take the square root of 4, for example, that equals 2, because 2 times 2 is 4. But it also equals negative 2, because negative 2 multiplied by negative 2 equals a positive 4. So whenever you take the square root of anything, your answer is always going to be a positive or a negative value. And the way you present in completed square form is you just leave it like this. Now we need to move this negative 2. We'll do that, we're going to add 2 to both sides, and that will result in x equaling 2 plus or minus root 3. And you can either leave your answer like that or write it out as 2 separate terms. So x equals 2 plus root 3 and x equals 2 minus root 3. If you ask to present your answer as the exact solution, then you leave it in surd form. This is a surd. So root 3 is a surd, and thus it's an exact value. Or you may be asked to present your answer to decimal places, and that means you would put this into the calculator with the requested answer. And here's another one. We're being told to find exact solutions by completing the square. So b is negative 7. b divided by 2 equals negative 7 over 2. We leave it as a fraction. Then we have x minus 7 over 2, close bracket, squared, multiplying out that bracket, that gives us 49 over 4, and we wanted 9, which is actually 36 over 4. So 9 is 36 over 4. So we've got to subtract the difference, and 49 over 4 minus 36 over 4, that gives us 13 over 4. Subtract 13 over 4, that will equal 0. And now we go ahead and solve. So we add 13 over 4 to both sides. That gives us x minus 7 over 2 squared equals 13 over 4. Square root of both sides. That gives us x minus 7 over 2 equals, now the square root of 13 over 4, I take that over here, is the same as the square root of 13 divided by the square root of 4, and the square root of 4 is 2. So that actually equals 13 over 2. So that means this is actually x minus 7 over 2. So that equals plus or minus root 13 over 2. Then if we add the 7 over 2 to both sides, we get x equals 7 over 2 plus or minus root 13 over 2. And we'll leave that like that as they wanted the exact solutions anyway. Then before we wrap up, here's a quick look at why we actually use completing the square. It's when a quadratic is in the completed square form of x plus p squared plus q. The q value, which is outside here, that is the y value of the vertex. And the p value, which is inside with the opposite sign, is actually the x value. Now the vertex is a turning point, so this means we can identify the minimum, the maximum, and the axis of symmetry, but we can also use this to translate, to move a graph. So here's the completed square form. This number here, that would be your y value, and this number with the opposite sign is your x value. Let's look how that works on a graph. If y equals x squared is the original graph, and that's this graph here, so that will have a turning point of 0, 0. Then if we add a outside of our bracket, this will move the graph, translate it a units up. So if a is positive, then that's going to move it up here. If a is negative, it's going to move it down. So that will move it in the y-axis. Whereas if we were to add a number inside the bracket, as here, then this will move, translate a units to the right. So if you notice here, this is negative. So if this is a negative sign, then the turning point, the vertex, is going to move in the positive x direction. If this is positive, this will move in this direction. I'll quickly show you one example. So you could be asked to draw the graph of y equals x plus 4 minus 3. So with that, we have to move the graph negative 3 in the y direction. So that means we're going to bring it down. So that'll bring it down, say that's negative 3. And then because we have a positive 4 inside, that means we're going to move 4 in the negative x direction. So that would be roughly here. So our new turning point would be about here. And that moves the whole graph to about there. And so this graph now has the equation of x plus 4 squared minus 3. I hope that all helped. What I would advise is rewatch the video, go back from the beginning, pause at each stage, skip forward to the areas which you struggle with, rewatch, try and do the questions yourself, make any notes, and then just practice, practice, practice. If the video helped, go ahead and hit the thumbs up, subscribe. It would be lovely to stay in touch. And if there's any other video you would like in particular, please do leave a comment below. I always read the comments, and I'm building up a library of content at the moment, and I'm more than happy to do something sooner than I had it planned in my schedule. And thank you, and I'll see you in the next one. Take care. Bye bye.